Okay, so this is Ktor. How many of you are doing Kotlin? Okay, I'm not going to talk about Kotlin as a language. I'm sorry. I already did that in my talk this morning, and I got such bad feedback saying, why were you talking about functions? I'm so sorry. I'm so sorry. Because like 75% of the room didn't know Kotlin, but okay. So I won't be talking about Kotlin. I'll be talking about Ktor. Ktor is an asynchronous framework for connected systems. Unfortunately, nowadays, that doesn't say much. Alternative title is asynchronous framework for distributed microservices backed with blockchain. I've always found that if I add microservices and blockchains to the mix, it doesn't matter what the talk is about, it sells way better. So you can make microservices, and of course you can use blockchain to do that. So it's absolutely fine. It's for everything. Anything you can and want, you can do with Ktor. But what is Ktor exactly? It's a server, it is client, it is multi-platform, and it's Kotlin through and through. So it's built from the ground up using Kotlin. Are you, just perspective here, who does web development server-side? HTTP endpoints, you use technology such as Spring or servlets or things like that? Okay. Ktor is also asynchronous. Ktor is also open source, which for us means it's free. Built and maintained primarily by JetBrains and inspired by other frameworks such as Wasabi and Kara. Kara, when we first developed JetBrains, when we first developed Kotlin, Kara was a framework which was kind of, it was an idea of bringing Ruby on Rails to Kotlin. If you're familiar with Ruby on Rails, that's what Kara was. Wasabi was something I created, which was basically bringing Express.js to Kotlin. If you're not familiar with Express.js, Express.js was inspired by Sinatra, which was inspired by something else, and so on and so forth. Now there's an actual framework which is bringing Ruby on Rails to Kotlin using Ktor. So we've gone full circle. So like everything is using everything now, and we're going back to the start. What can Ktor be used for? It can be used to create server-side applications, which means HTTP APIs. And please, I'm talking about HTTP APIs, not REST. REST is, so generally when you say, are you creating RESTful systems, people understand RESTful systems as HTTP verbs with nice JSON and nice URLs. That's not REST. So you can create HTTP endpoints and serve back any kind of data you want. You can also create RESTful systems. But RESTful systems you can create with anything. RESTful, if you're familiar with it, it's basically complying with a series of constraints. It's not about the technology you use. It's also for sockets. It's also for client-side applications. It is multi-platform. What are Ktor's goals? To remain simple. So the idea is to create a simple framework that you can use to create your applications and not delve too much in the actual framework itself. It's to be flexible, meaning that we don't ship with everything out of the box. So if there's something that you need, you can add yourself. It's to be performant, and it's to be cross-platform. And it's funny that I've actually made this slide, because every time I read it out, I'm like, would I ever make a slide that says Ktor is meant to be complex, very rigid, really bad performance, and hopefully it'll be cross-platform, right? I would never do a slide like that. Like everything starts out simple. So does Ktor. And I'm sure that in 5 years we'll be like, oh yeah, now we're going to do a new version. It's called Ktor Boot, right? No reference to anything there. So a simple server. To give you an example, this is basically the simplest code you have for Ktor to get an HTTP endpoint up and running. So the first thing that we do is we create a server, and Ktor can use any kind of like transport protocol, so to speak. And by transport, I don't mean the actual HTTP or SMTP or anything like that. I'm referring to like the underlying mechanism that does the HTTP connections. So in this case, I'm using Netty. And I'm saying create an embedded server, which means that I can embed this in my application, use Netty as the engine, set it on port 8080, and then I want to create a single route or route, depends on where you're from. I want to create a simple route that responds to the index page, and then that index page is going to basically respond with a single line of text, which is hello Ktor, and the response type is text HTML. Now this is technically not correct, because that should be text plain, because I'm not sending back HTML, but it works because browsers. Okay? So this actually works, and it sends back an HTML. This is the simplest you get with Ktor. You don't need anything else. Now, a Ktor application consists of a bunch of modules. So you can have a Ktor application, and then inside that Ktor application, you can have different modules. You can have, for example, a customer module. You can have finance module. You can have different things. Now, modules do not align with the concept of controllers. So if you're familiar with Spring Boot or any other kind of technology like ASP.NET MVC or whatever, you have the concept of controllers. A module can be a single controller. It could be multiple controllers. The idea behind modules was to basically create isolation that could serve under the same application instance, and then you could move these around. Generally, what we found, though, is that people mostly just stick to a single module per Ktor application. So it doesn't mean that you have to have multiple modules. Inside each module, what happens is this pipeline. You get a request that comes in, that goes to a routing mechanism, then your app logic comes in, you do whatever, and then you respond. Now, Ktor has this concept of features, which is another way of, depending on, again, what framework you're using, you can call them different things. Some people call them interceptors. Like, for example, in Wasabi, we used to call them interceptors. Other people call it middleware. If you're familiar with Node.js and Express.js, you have this concept of middleware, which essentially means something that is in the pipeline that is going to intercept the request. And you can have these features anywhere. Like, I've put them here between the routing and the response, but you can have them pretty much anywhere in the pipeline. And then these features can be different things. You could have, for example, encoding, you can have compression, etc. But what's cool about Ktor is that routing itself is also a feature. So this is just a feature that kind of like is by default installed. So everything pretty much in Ktor is a feature, which means that it's pretty flexible and what you can do with it. So with that, that's all that we have in terms of slides. And we're going to now switch over and see some code. Did I lie? Do we have some more slides? We've got 3 more afterwards. Okay, so some code. Now, I'm going to start with a very simple thing over here. This is the example that we saw in the slides. Okay? Now, notice that there's something missing here, and what's missing is that I'm not actually creating an instance of a server. And I'm not saying that I'm going to use Netty, and I'm not going to set the port. And the reason for that is that generally, you wouldn't do this on an application that you want to deploy. On an application that you want to deploy, you want to try and keep the information about what type of server I'm using, what type of engine I'm using under the covers, etc. You want to keep that outside of the code, right? You want to keep that in a configuration file. And in this case, this is what we're doing. So in my resources, I have a file called application.conf. Okay? And this uses its own language, which is called, well, its own. It uses HOL. And what I'm saying here is that I've got this Ktor configuration, and it's going to be deployed using port 8080 and on this port, right? And then what I will do is say I want this module to be loaded. So I could actually load all of these modules at the same time. When we were talking about having multiple modules, you can actually load all of these modules. But for this walkthrough, I'm going to take it step by step and just show the different modules. So in this case, I say I want to launch the simple application, right? And now this is going to use this application over here, which is the one that I actually run. And this is saying, in this case, use the engine Netty and read the information from the application config files. So by default, when I pass args, and args are default, if it doesn't find any arguments on the command line, it's going to look for an application conf file and then load that information from there. So it's quite versatile in that you can actually pass other parameters even if you have your own application conf. So every single time I run a sample here, I am always running this same main function. The only thing that you'll notice I'll change is comment out one module and uncomment another module. So let's run this. And then what we'll get is essentially the functionality that we saw here, which is the simple. So you see how quickly it starts up. Like, it's immediate. Okay? As soon as I run it, it boots. And then I can just click on the URL, and I get my hello world. Okay? Pretty simple, yes? By the way, that is the simplest thing that you can do. But we also have a website. Okay? It's not great in terms of marketing, but it works. And we also have a website which is called start.ktor.io. I don't know where that idea came from, but hey, we have it, right? So here we have, like, you can say Gradle project, Gradle with Kotlin DSL, Maven project, and select the version of Ktor, set everything, select the different templatings that you want. So you can see that already we come with a whole bunch of features, right? And then select whether you want to create a client or... This is a little bit confusing because, like, I would never create a client and an engine really at the same time, although you could. And then you can build this, or you can install the IntelliJ plugin. And if you install the IntelliJ plugin, if you go to File, New, Project, and click on Ktor, you basically have the same thing, right? So you can go through the steps here and then generate your project. So that's the easiest way for you to get up and running with a Ktor project. So now let's go to the next one, and the next one is going to be static. So one of the things that Ktor allows you to do is basically run, serve also static files. So in this case, I've started the application. If we look at the static, what I'm essentially saying here is that I'm now defining a routing, and we'll dive into the routing and all of that a little bit later on. Don't worry about it now. Right now, this is a lambda. If you're not familiar with Kotlin, this is a lambda. So, well, this is not a lambda. That's a higher order function. This is the lambda. Inside the lambda, I'm defining another higher order function that takes a parameter which is called static, and then some other block of code. And this static is basically just saying that anything that is in the resource static is now static. You can just respond and serve it. And resources is where the files is located. So I have a Kotlin logo.svg here, which means that in the browser, if I were to do localhost 8080 and then do static and then Ktor logo.svg, I should get back the SVG. As simple as that. You want to serve static files, you just say static, the URL, and away you go. Okay? Next example. Let's take a look at HTML. Now, if you're familiar with Kotlin, you know that we have this library which is called Kotlin X HTML, right? So if you come here and say Kotlin X HTML, it's a Kotlin DSL for creating HTML. So this is basically the static typed HTML, kind of like the groovy HTML builders, except this one is statically typed. So we use that as part of Ktor as well. Like, it's not built into Ktor, you could just reference it and then use it. So in this case, what I'm saying is I want to get back some HTML DSL, and I'm going to do call respond HTML instead of respond text in this case. And then inside my body of the function, I'm just basically writing HTML, which is a DSL that Kotlin is providing. So headers, UL, and of course, this is essentially Kotlin code. So I could do anything I want. If any of you have done any kind of server development from the very, very old days, like very old, I'm talking CGI, ISAPs, anyone? Right? Back then, we didn't have this concept of smart and server, what are they called? The single-page apps and all of that, right? We used to serve all of that crap from the back end. And hey, it used to be efficient and fast, but there you go. So now you want to create a website and you pull down like literally 200 megabytes of Node.js files. But we used to do this, right? We had a templating engine which said, I'll just loop through everything and get the data and render out the information. And you could do exactly the same here. You're mixing Kotlin code with HTML code. And those people that scream, oh my God, what about separation of concerns? What about React? You're doing the exact same thing with React, right? Except they call it JSX. Okay, so this one, now I could just do HTML. So let's go on this one over here, and I'll do HTML DSL, and you can see that this gives me back HTML DSL, right? And if we do the view source, view page source, you see that it's nice and clean. None of that rubbish that's been added to it. Well, rubbish. Overstatement. Okay, I won't say rubbish. None of that unnecessary garbage that's been added to it. Okay, so now everything that we've seen is basically a get, get, get. But of course, Ktor has support for multiple verbs. One of them is post. So how do we post information? So in this case, what I'm doing is showing you two things. So now I've got a routing where I can, in the root, I'm just getting the response, and I'm setting the content type, and I'm responding with HTML. So I'm actually generating the form, right? And in this case, I'm generating the form post, I'm setting the content type, and then I'm adding a paragraph, and I'm adding a form, and in that form, I have two types of input fields. I have a text input field, and I have a file input field. And then I have the submit button. All of this, again, is statically typed, right? You don't have to, like, it's there. You get completion and everything. And then I have another route, which is the post form, which is actually going to get that response. And take notice of this, because this is something we'll take a look at later on. This form here, obviously, has to coincide with that action over there. So now what I'm doing is I'm saying, if this is multi-part, which comes in as the request object. So notice that all of the things that I've been showing you here, there's not been like a request response. There's been a call. So everything comes through this property call. And the call has a request and a response. Call is the main kind of like conduit that you use to communicate with the outside world. And it provides you with that consistency, whether you're using a socket or whether you're using an HTTP request. I say if it's multi-part. If it's not multi-part, it will send back an error. And then if it's multi-part, I just go, for each part, I have a property multi-part. For each part, I go through them. I can list the file. I can access the file. I can do anything I want with it. So to run this, I just basically go to the root page. So I get my form. I can type in something. I can say choose file. I can come here and say whatever, and open this and send, and you can see that I get all of the information back here, which is the file name and the content type of the application. Okay, so out of the box, you get support for multi-part forms. You get all of those functionalities that you would expect for any kind of like, uploading of files, etc. Next example. Are you following me? Any questions so far? People rarely ask me questions. I always wonder, like, are they just sleeping, or? I try and think to myself, I explain things so well that there's never any questions. Yeah, keep dreaming. Okay, features. So that is, yes. So now let's dive a little bit into the features. Then we'll see some other things that we're adding. So now notice that I've added a new line to my code. In addition to the routing, now I've got this thing called install. And what install does is it installs features. So when I want to add certain functionality to Ktor, what I do is I just do install and the actual feature that I want to install. And in this case, I'm saying install default headers. So generally, if you were to create a new application with Ktor, the template would generate a whole bunch of default installs for you, right? And this one is the default headers. So now by adding this, it is going to give me back default HTTP headers. If I were to remove this, I wouldn't get that information back. So if we come here and I say, if I come to the correct one and I say, because I keep making that mistake, localhost 8080 headers, you can see that I'm getting back the headers, right? You can see that I'm getting back all of these headers that by default wouldn't be coming back. Okay? And all I had to do was basically add this install and the name of the feature. So if you're familiar with kind of like Spring Boot, this is where you wire up all of those different additional functionalities that are provided with Spring Boot. This is kind of the equivalent thing. Okay? Now, this now allows me to add some other features which are way more important than default headers and more useful, one of them being JSON. So let's comment this out and go to the JSON. So JSON here is doing something else with the headers. It's doing something else with the features. The first thing it's doing is saying install content negotiation. So that in itself would install content negotiation. Are you familiar with the concept of content negotiation? So content negotiation basically is the way that a request response works to get the resource in the format that you want. So when you send an HTTP request to a server, normally in the header, and if we have it open here, you can see, normally in the header, you have this accept. See this accept? This is a perfect example. See this accept header? What this is saying is the client is sending an accept and saying that I will accept text HTML, application XML, image web, etc. I will accept all of these formats. And then there's a queue with a number. That queue represents the weight. Okay, and the default one is 1. So generally what content negotiation does is that when it sends a request to the server looks at the accept and says, okay, you are accepting all of these types of content types. Let me see what I can serve. And I will serve it to you based on the priority you're giving me. So first one, then lower queue, and so on and so forth. That's what content negotiation is. So when I send a request and I put application/JSON, it will see if it can serve JSON. All of that is kind of hard to implement. Well, it's not hard, but it's tedious to implement. All of that is already provided for you by just doing install content negotiation. But in the case of Ktor, content negotiation does something additional as well. What it also does is basically do the encoding for you, right? So, or the formatting, whatever you want to call it. So inside content negotiation, inside this feature, I can have configuration parameters. And I'll show you how to create a custom feature with custom configuration parameters. But inside this, I can now have custom configuration. And in this case, I'm saying I want to use JSON to serialize my data. And JSON, of course, has its own custom parameters, like set pretty printing, right? It has a whole bunch of different parameters that I can set, that I can configure so that it works appropriately. So by doing this, I already now have content negotiation in place, and I have my code, whatever I respond, automatically serializable to JSON. So in my routing, right, this is the startup. This is basically configuring my app. Now I'm defining the routing. When I do get customer, notice that I'm doing model customer, the name, and then I'm just doing respond with model. I'm not doing any kind of get this and serialize it to JSON and use Jackson or whatever. I'm just doing respond model. And that will automatically respond with the information. So if I say, for example, customer, it will die on me. Oh, did I not start it? Oh, yeah, let's start it. Okay, so let's close this. And I say customer, it will get back my JSON without me having to do anything. So you got support for JSON, you got support for XML, you got support for any kind of thing, and you can plug in your own model. We have support out of the box for Jackson and JSON. You can extend it and add your own serializer if you want to do. We also have, I think, now support for Kotlin serialization. It would be kind of awkward if we didn't. Okay. So that's actually quite a lot of work that is saving you from doing every time, right? Now I know a lot of any basically application framework nowadays has this kind of functionality inbuilt, and you have it here as well. So next, authentication. We have that too, and it's kind of nice. So authentication is quite simple. We have this concept of, again, we have a feature which is called authentication. You have different types of authentication. I'm showing you here basic authentication. If you're familiar with basic authentication, that normally has a realm, which basically means what area it's covering. So I give it a name, and then I have a lambda that allows me to validate the request coming in. Okay? So the validate basically takes credentials with some sophisticated technique. I validate the credentials, and then I set the user ID principal. The user ID principal is something that comes in Ktor. So you set that, and now it's associated to that request. Okay, so in this case, I would say credentials name, and otherwise I would return null. So now I've defined my feature authentication. I have added a basic authentication, and here I could add a million. I could add another basic one that says blah blah, okay? And blah blah would be another realm, or it could be another different mechanism for authentication. So, but all I've done right now is just define it, define how that authentication is. Now, how do I use it? So in my routing, here, this call doesn't have authentication. I can actually call this and everything is fine. But this call over here is wrapped in authenticate, which means any routes defined below authenticate need to be authenticated. Okay? So if we run this, localhost, 8080, and then this was going to be the root. So here, no need for credentials, but if I put auth, if I put secure, sorry, not auth, secure, it will prompt me for authentication, right? So if I put Hadi, it won't work. Hadi, it will work. Okay? So we provide basic authentication, I think LDAP, and a bunch of other integration with authentication providers. OAuth we provide as well. So that's all available. Okay. We're nearly there. See, if I finish quickly, we can leave. So, you've seen a bunch of features that are built into into Ktor. How do you go about creating your own feature, which is very useful? Like one feature that isn't built into Ktor, which I very much like and I had in Wasabi, was what I call auto-routing, which essentially means that if you're familiar with the ideas behind REST, one of the things that is good to do is you treat, with REST, the idea is to move away from verbs and move to resources. And then you apply things on these resources. So sometimes if some resource is not applicable, let's say, for example, you have a customer and you can't do a put on a customer, you should respond with option not allowed or method not allowed. So the auto options, what it would do is add all of these auto routes so that it would automatically respond with that, right? So with a custom feature, what we do is essentially it consists of two parts. The first part is the configuration. So the configuration is similar to what you saw, for instance, for the JSON. Sorry, for the content negotiation. You saw that I could do like JSON, and then inside JSON I had set pretty URL, all of these things. Or when you saw with the with the authentication, you had basic, etc. So these were different things that you could tweak for that feature. So you define your configuration, right? So here I'm saying I have a class configuration, which in this case only has two properties that I can configure, a header name and a header value. And that is the actual configuration. That's what's being included in the setup of the feature. But the feature also actually has to do something. It has to intercept the pipeline and process the request or the response at some stage. And that's where the pipeline comes in, and that's where you actually implement that feature. So in this case, I'm implementing application feature, which basically gives me access to the entire call pipeline. And then I'm saying, I'm installing my feature, and I'm doing some of the work in the intercept call. So in this case, I'm just adding custom headers and sending those headers back. Always the pattern is the same. When you want to implement a feature, there is the setup configuration. So that's defined in your configuration, which is an nested class. And then you have a companion object, which actually implements the functionality of the feature. And that's basically the two steps that you have to follow to create features. Now, the cool thing about Ktor is that in many frameworks, you can generally frameworks give you the option of saying, okay, you can install an intercept or middleware in the pre-request, post-request, pre-response, post-response. With Ktor, you can basically insert it anywhere. And you can prioritize one feature over another, and you can basically get access to all of the features and change them and reorder them based on how the user is installing them, etc. So now that I've defined this custom feature, how would I go about using it? Well, exactly like before. Install. Here comes the configuration part. And that's it. Okay? So now if I were to run this, what it's going to do is when I call the root, it's going to respond with a custom header and a custom value. So if we open this out and we go to network, you can see that I have the custom header. ABC, and then the result DEF. Okay. Creating custom features is very simple. And someone asked me recently about Ktor, like, you know, do you have support for IOC containers, right? By the way, if you want to use an IOC container, Arnold's in the room who's created Coin, so I'm not going to say like Google did and say use Dagger. I'm going to say use Coin, right? Doesn't matter what you want to do, use Coin. So point is, like, could I use an IOC container with Ktor? Of course you can. You can wire up things whenever you want. If the IOC container is something that actually has a registry and things like that, you can also install it as a feature. We don't have a specific feature for any of the IOC frameworks, but you can see how easy it is to actually create a feature for that. And that's something you could do, right? Create a feature for, Oh, there is one. Oh, excellent. There is one already for Coin. There you go. So you can install the Coin IOC. Excellent. So now when someone asks me, hey, what IOC framework should I use with Ktor? I'll say Coin. Supported. I don't know if you got the reference, but recently there was a dev summit, and Google had this talk which basically was saying, if you want to use an IOC container, just use Dagger. It's like, that's it, right? Okay, private joke, which is being recorded, as always. Okay, so now let's go back to this example here. Notice that when I'm defining my routes, I'm doing routing and then get, post, etc. You can start to realize that this is going to become ugly and unmaintainable, right? Because it's like, okay, I've got two routes here, and I'm putting all of my application logic here. What happens when I start to like have a real business application? How could I divide things up? How could I organize things? And the good thing about Ktor is that it's quite flexible. It doesn't really care how you want to do it. Like, it doesn't restrict you in the way that things like, for example, Spring Boot restrict or push you towards. Of like, you know, if you want to have a URL that responds to customer, then create a customer controller. And then basically everything has to be in that customer controller. With Ktor, you can put your routes in classes, you can put them in files, you can put them anywhere you want. You can define them like this with routing, or something that you kind of use as convention is this mode, right? No, not this mode. This is another example. So here, what I'm doing is I'm defining my routing. So I've got get, and then now inside get, I have customer. Sorry, I have get, then I have customer. I have employee, and I have shipment. So I'm dividing my routes up by 4 segments. So this could be the equivalent of controllers. And inside these, then I can have gets, posts, get, post, etc. So you see, I don't have to actually do like a get customer and then a post customer. I don't have to do this. What I can also do is organize my routes in the way you see here, right? Which is basically have root customer, and then inside of that have the different actions. But this is all still in a single file. And I want to move away from this. Now, of course, you can do, instead of doing call respond text, just delegate that to a function. But it would be nice to group things better. And that's where you can basically just kind of like, you know, define an app structure. So the easiest way in the convention that people generally use is essentially kind of have a file. For instance, this one I could call home controller or home routes. And then inside that, define my home routes. I could define them as single functions. I can define them as multiple functions. I could define them in multiple files. Here you really have flexibility. And it really depends what you want to do. If you want to move from functions away from functions and move to classes, if you want to have IOC containers, you need those classes, you need to inject dependencies, it's absolutely fine. At the end of the day, all root is a function. That's it. So it's just where are you going to call that function, which is going to essentially register that root. Okay? I won't run that one. I'm sure you trust me in that it's going to work as well. Okay, so the app structure is also working. And now let's go to locations. Now, coming back to this example here, you notice one thing. I said focus on. Here I had the action form, and here I had the post form. Now, if you're using a tool like IntelliJ, if I do a refactoring of form, it'll probably say to me, hey, I found this other form string here. Do you want to replace it? But we want to try and move away from strings. We want to have static typing. And that's where the concept of locations comes in with Ktor. Disclaimer, I hate the word locations, and I'll explain to you why. Also, this is kind of experimental feature. That's why I've got this use experimental at the top. So the idea behind location is essentially to create a strongly typed root so that I can refer to that strongly typed root and not use strings. So here what I'm doing, I'm saying I'm creating a location slash which corresponds to the class index. Here I'm creating a location employee ID which corresponds to employee. Notice that I'm using the convention of lowercase because it's not really a class. I'm just kind of hacking this. And this employee has an ID of type string. So now when I do an install routing, this is no longer a string, but it's referring to the type index. This is no longer a string, it's referring to the type employee. And the cool thing is that this is now giving me strongly typed parameters as well. Because if you looked at the previous example, not in this one, let's see, routing. God, what am I doing? You can see that when I call employee and the employee has, like, for example, ID on the root, I have to call that as call parameters ID. Yeah? If I start to use the concept of locations, I can start to basically define all of my properties in a strongly typed way and then get completion, get all of the benefits of refactoring, etc. Now, I said I don't like calling this location. I think it's a misleading term. Why? Is anyone familiar with the location header in HTTP? So location header is actually very, very useful. When you, if you're familiar with, again, the concept of post basically, what does post do? Post creates a resource, right? Post creates a new resource on the server. So often someone says, okay, what happens if I do a post of a customer? I'm creating a new resource of a customer. How can I get back the ID of that customer? Let's say that ID is generated on the server side. How can I get it back? A lot of people, what they do is that they respond with a JSON containing the ID. But did you know that in the HTTP specification, there is actually a header for that? It is called location. Location actually contains the resource that was newly created. It creates the URI of the resource that was newly created. And you can use that for responding. That's why I find this a little bit inappropriate word, misleading, because it's got nothing to do with HTTP header location. And hopefully one day they will rename it. Okay? So, async. Now, one thing that I said to you is that Ktor is built from the ground up using coroutines. So who's familiar with coroutines? Right. Coroutines is basically our way of, if you've ever done kind of like async await in C#, it's kind of like that. It's to do non-blocking programming in Kotlin. But we use the concept of coroutines, which is basically you have a function and then you can call some other function and suspend this current function and then resume this function. If you're familiar with Go, it's kind of like the Go routines. So we use coroutines. So under the covers, most of this are suspendable functions. But what happens with our code? What happens if I want to create code that could potentially block? So generally, Ktor should kind of take care of that for you. It kind of has mechanisms in place to prevent you from blocking more requests coming in. But the recommendation is for you to use a simple pattern. So here, for instance, I have, where's my routing over here? Right. So here, for instance, I have a respond HTML that just responds with some data, and then it computes some information. And this compute is a suspendable function, and it's launching it in a coroutine context. Okay? So when I'm configuring my routing, I just do application async, install my headers as usual, routing, get. Everything is essentially the same. Everything is essentially the same. I don't need to do anything different here. The only thing is that what I would like to do is, if something is long-running process, create it as a suspendable function, and then use the coroutine context to launch it. But from this coroutine context, you actually have access to all of the information. So you don't need to worry about syncing with a main thread or anything like that. You can basically get the results and pipe those results back directly in the HTML request. So this is kind of the pattern that you would follow so that you avoid potential, blocking incoming requests because your process is kind of long running. And then finally, we have the testing. So the whole concept of call, all of that is abstracted away so that you don't have to set up the entire stack to be able to do testing of your application. Now, if you're doing integration tests, you can launch your own server, run those integration tests. But if you just want to test the logic of your request response, you don't need to do that. Here, for example, I have an application that is testing, and I've just passed in a parameter that's testing Boolean equals false, right? So in my application test, we have this function which is called with test application. I call my testing, I pass in true, and then basically all of this runs without my server needing to run. And it will do all of the logic. You could basically do any test on the logic, on the request response, and you don't have to worry at all about setting up the entire stack. Okay? If you want to, of course, you can, and it's kind of recommended that you have your integration tests. But for testing the logic of your routing, you don't need to do that. Okay? By basically just passing testing equals true to your application. Okay. So with that, you've kind of seen an overview of the features and functionality that Ktor offers. To summarize, I've shown you most of the examples in Netty. Well, all of the examples are in Netty, but we also support Jetty, Tomcat, Netty, and CIO. Anybody heard of CIO? It's coroutines IO. Do you know what that star means? It means don't use it in production. We are experimenting with that, which is basically we're getting rid of Netty, we're getting rid of Jetty, and we want to build everything from the ground up. So that is still very, very experimental. Okay? Containers, we support Tomcat Jetty. It supports Java 6 through to Java 12 already. I just didn't update the slides. I can't keep up with the Java releases. I think we're Java 16 right now? Google App Engine, Heroku, Docker containers, all of that again is supported. To give you some insight also to know that we're committed to this, we are launching a new product soon, which will be announced. And what I can tell you right now is that it's a multi-platform project in Kotlin through and through, including JS, mobile, and it's server-side as well. And the server-side is built from the ground up using Ktor. So we've got skin in the game, which is something often to take into account, right? When you're adopting some frameworks, you sometimes have to question, and we were talking about this earlier on, you sometimes have to question if the people that are creating that framework also have some skin in the game. Are they using it themselves? And I'm not going to name any specific frameworks such as React Native, but it's important to know about this. Okay? So if you want to learn more, ktor.io, start.ktor.io, and that's it. Thank you. And we have 4 minutes for questions, so you can either ask, or if you don't have any, you can just walk away. Up to you. And don't feel bad. If some people want to stay and ask questions, it's fine. The rest of you can go. Yes? You want to say thank you? So so the question is, throughout the entire demo, you saw the server start up very fast. What is the magic? There is no magic. It just starts up very fast. Yes, the other servers usually are slower. But yeah, there is no magic. It just starts up very fast. We don't have a lot of overhead to start up a Ktor application. There is no trick. Like you could this source code, or everything I've shown you is available on GitHub. You can pull it down yourself and run it, and you can see. Yes. What would be the advantage of the CIO Well, technically, the advantages of what would be the advantages of the CIO, well, the idea is that it'll be like through and through even more Kotlin. It's ours also trying to experiment with the coroutines and hopefully be performant and not have some dependencies on external things. And also remember that our goal here is to make everything under the Ktor umbrella multi-platform. Right now, the client is. So right now, the HTTP client in Ktor, you can use it from Kotlin JavaScript, Kotlin native, or Kotlin JVM. The server, you cannot. When we have CIO, then you will be able to. Any other questions? Okay, did you like the... There is no trick to it, I promise you. Okay, great, thank you then.